Yeah, I know we have it off. I don't know if they're, oh, for staff is who I was wondering.
Oh.
I know I have it off. I'm not coming.
Oh, I just it's a Monday.
All right. I'll give you a second to get set up. So I started the video. At the beginning of the video, there may be a couple of dead minutes where we let people set up. I'm always surprised people don't complain more about the videos with all the spots in it where I'm troubleshooting for people and yeah, fast forward, yeah.
There's no way for you to pause it while you're recording.
I have tried. When I pause it, it kills it. And there may be a way to do it. I haven't figured it out.
Yeah, we can fast forward.
Yeah. Now the other, I haven't tried Panoptico. I've always kind of not wanted to try it because it's a Flash application. And I don't know how that works on iOS or because I mean Apple is dead set against Flash, and even Microsoft is not installing Flash in its things happily anymore. So you want to do click the little plus there,
It has to be
and then it'll probably did we save the
We did.
so then open the little plus. Okay, so you have to do yeah. And then
Let's see.
Now we're.
okay, and then like the community assistance on follow this right click on it. And then query.
Or we use Spider Oak. That's really involves like password management and data.
So we're going to do joins today. As I was saying kind of before class, I would kind of like to get to the point where I would do the lecture on Tuesdays and the lab on Thursdays. It seems wrong to me to do it the opposite, but that's sort of how they're falling. So joins. How many of you have done joins before, at least some? We did, I mean, tiny bit in 220. Yeah, and you did them, yeah. So joins are a way of bringing the data back together, right? When you do database design, you split all your tables up into, each one is about one thing. A lot of tables. Let's just do like employee. Just a lot of tables end up with just numbers in them, right? And that's great for the computer. It's not necessarily good for a human reader. So joins allow us to bring the tables back together. I'm going to start off with a join that you probably will rarely, if ever, use, which is a cross join. You guys know what that does? Yeah, so it joins every possible thing. So I'm going to join, let's just do two tables. Let's do, I'm going to do select star from employee, and we'll cross join position. Spelled right would be good. All right, this is an explicit cross join, and it's what I would recommend. It has the actual words cross join. All right, so when we look at employee, so what we have 7 records, right? I'm also up here, I'm going to do a quick one from position. So when we do position, we have, what did I call it? What's the actual table name? I didn't call it position, job position, job position. employee position matches the employee to the. So I'm going to run that. Okay, so we've got 8 of these. So there's what? 8 and 7. All right, so when we run the cross join, now what? Oh, it's job position again. Brain. All right, so when I run the cross join, we have, if we look at messages, there's 56 rows, which if you think about it, is 7 times, the other one. So notice that, let's order by too. It's clearer if I do an order by. We'll do order by employee key. And you need to move the semicolon. So employee 1 is matched to every position, all 8 positions. Employee 2 is matched to all 8 positions. Employee 3 is matched to all 8 positions. That's what a cross join does. It takes all of the records from one table and matches it to every single record in the other table. It basically gives you all possible combinations. It's not forbidden. In fact, there's an actual join for it because there are times when you do want to see every possible combination of data. Not often, but there are times. Generally, though, you don't want to do this. So we have 2 really small tables here, and it came out to 56 rows. Imagine if you had 2 tables with like 1 million records each. 1 million times 1 million. You could actually freeze up your RAM if it tried to process it all at RAM. Cross joins they have their uses, but they're pretty infrequent. One of the things I want to show you is you can get a cross join by accident. I'm going to do just the same thing. You'll get exactly the same results. I'm just going to do comma job position. And I've seen people do this because they think it's the way to. I will do the order by also. This will give us exactly the same thing. Ordery by. And now it's or day by. All right. I don't need to. So that gives exactly, again, and once again, with 56 rows. So if you just list the columns without explaining the relationship you get, the tables, if you just list them without explaining the relationship, you also get a cross join. This is an older syntax. I'll show you when we do an inner join. There's an older syntax too. I would always argue for the explicit keywords just because it's clear what you're doing and you know you're not doing it by accident.
So cross join basically combines 2 tables.
It combines every combination of 2 tables. It's not just combining the 2 tables. It is taking every record in the first table and combining it with every single record in the second table. So the result set is basically the number of rows in the first set times the number of rows in the other table. So if it were 100 times 100, it would result in 1,000. If it was 1 million, it would result in 100 million. Basically, it's just times time. Right? It literally takes every employee and matches it to every possible position. Now, when I was trying to figure out what applications actually ever use this, some kinds of scheduling things look for every combination. right? So scheduling might be one of the kinds of things where you look for every possible combination of rooms and events and things like that, particularly if you have a place like the school here where typically, say from 9 to noon, every room is full. So trying to schedule things can be a little bit insane. They also, for some kinds of mathematics, they do that.
Steve, so looking at this, the job position comes from employee. Where does it, excuse me, employee
job
comes from employee. How does it know where to find job position?
We're just told it to compare those two tables.
Oh, it's the entire table.
It's the entire table. And we're getting the position key, because I did star, I'm getting the position key for each of these too. I don't know why Postgres doesn't order these naturally. Unless you order by, they come up in bizarre combinations sometimes. We could do a second thing on position and position key or something. But each person is matched to each position, right? So it's every possible combination of persons and positions. I want to show this, as I said, because it is a legitimate type of join. It can happen on purpose if you have a reason for it. It can also, when we do an inner join, there's an inner join syntax. It's an older syntax that does this for the tables. If you screw that up, you get a cross join by accident. And the way you know is you just get a much bigger answer set than you're expecting.
Steve, 2 questions about these tables that we create. One is,
Sure.
Are they stored anywhere? Or they're there only temporarily while it's up?
Well, these are tables in the database.
No, I mean the one we create.
No, these are just result sets. They have no existence.
So you can't refer back to that in your next command.
No, not unless we create temporary tables, which is something we'll do later. You can create temporary tables. You could write this to a temporary table, which then would allow you to requery it. And in fact, that might be a use for it. This might be the first step of something that you're doing later, right? So you look at every possible combination, and then you query that to find certain higher value combinations. You could do that. I mean, we will, when we talk about tables, I'll show you how to create temp tables as well. Temp tables exist for one session. As soon as you cancel the session, the table is gone, but they're there for the duration of the session. So you can use them while you're logged in and working. Once you close out, it's gone.
Once you change databases, it's gone. That you're working with.
What do you mean?
So you're doing analysis on Community Assist. If you shift to another database,
it depends. If you leave this open, so you can always, as long as this window's open, you're basically in session. If you close this query window, it would go away. Or if you logged out, it would go away. I could go to another database and leave this window open. If I go down to, is it down or up? Yeah, down. So if I went down to tech review or tech certificates and did another query tool, it wouldn't kick me out of the other one. What I have is 2 of them here. This is tech certificates. So they're just tabs up here. But once I left, this is actually for like a later discussion, but once I not just move out of the window to another window, but once this window closes or I log out.
Can you work across 2 different databases?
It is possible. That actually is a good question. In SQL Server, it's definitely possible to query across databases. I don't know that Postgres lets you do that. I will look. It seems to me like I tried it and was told I couldn't do it. Okay, so that's a cross join. So I'm going from the one that you're least likely to use to the one you're most likely to use, which is an inner join. And these are probably the ones that you've done. Inner joins only return matching records. Does that make sense? So person table has like 132 tables, 132 rows in it. But if I do select, I'm going to do person last name, person first name. Let's do, I don't think there's anything in employee, right? Except for the employee. Let's see what else is in employee. That's it. Yeah, just the person key. So I'm going to just select those two things for each employee. So I'm going to say from person, but I don't want to see all the people. I want to see only the employees. Inner join employee. And then you have to say how they relate. So I am going to say on person dot person key equals employee dot person key. Employee dot person key. So that's how the two tables relate. The primary key, foreign key, right? Just as an aside, you're not going to do a lot with it, but they don't have to be primary key, foreign key relations. If they have any two fields in common, you can do it on those two fields. That being said, that's bad database design. If that's a possibility, there may be something wrong with your database design. But they don't. There's nothing that demands that they be primary key, foreign key, and it also doesn't matter. You can flip the order, right? That doesn't matter. But that's telling how the tables relate. And when I run that, it gives me only, when I say it only returns matching records, it's only returning those people from the person table who also have keys in the employee table. So only where they match. Does that make sense? Inner joins always return matching records. Questions on that?
So, yeah, I don't know. So it's taking the first name from
Person.
one table.
These both are in the. These are both in the person table. Now we're going to move. I'm going to add some fields from other tables too. We're going to build this up a little bit. Like we might want to know what position they have, right? And maybe the date they started on that position.
Saying that list is only employees.
These are only employees.
And the table person.
So it's not in the table, the first name, last name. So let's add employee key. So I'm just adding employee key. I'm adding it first because it makes more sense to me there. And we could order by employee key, but this is their employee key. This is coming from employee key. Right? These are coming from the person table. We're joining it, and it's returning only matching records. So if we look at the employee table, we could add their person key too. Although if we do that, I have to qualify it. Actually, I'll run it without and show you the error. Right, because it'll throw an error. It says it's ambiguous because it doesn't know what table person key is from because it's in both. So I'll say person. With an inner join, it doesn't matter what table you choose. Okay, because it only does matching. So here's their employee key. Here's their person key, last name, first name. These are the same person keys that you will find in the employee table. If you want, I'll run it the employee table again.
What is the person that key?
So this is the table, this is the column. So we're saying up here, it needs to know what table to take the person key from. In an inner join, it doesn't matter because it only matches or takes matching records. When we do an outer join, it does matter. That's later.
So the person key is the primary key in table person.
Yeah, it basically, it is the primary key in the table person. It's also the foreign key in employee.
And the first and last names of those people are in both tables.
In the employee table, there's only the numbers.
Oh, I see. Okay. This all makes sense.
See, if I do this, there's an employee key, and then there are the person keys. That's all that's in employee. So if we want to know the employees' names, we have to get those names from the person table. All the people in the database, whether they're donors or employees or asking for grants, are in the person table. Yeah.
So Steve, you refer to person key as the linkage, and you define it come from the person table. Would the output look any different if you said take it from the employee?
Well, it wouldn't matter if I flip these, but it has to be person key. It has to be what's
It would
related.
be in the same order and everything?
I do. I don't know if it'll be in exactly the same order. Let's look at it and see. I mean, it really shouldn't. It doesn't matter
And then change
logically.
that it's coming from the employee.
Well,
Okay.
you mean change up here to employee?
No, person above that, where you reference that it's coming from the person key coming from person instead of from employee.
Oh, yeah, that wouldn't matter at all. It just needs to know what table to take it from. And with an inner join, it makes no difference whatsoever. Couple of things. Is that clear yet? Does it make sense? I could draw some pictures. So we're taking data from two different tables. And the thing is, with inner joins only return matching records, right? It ignored all the people that are not in the employee table. So there's like 132 people that ignored all but 8 of them or so. 7? I guess there's 7. So it ignored all but 7. It only returns matching records. Couple of things that I'm going to show you real quickly. This is the exact same thing. Inner is always an optional word. If you just type join, it's going to assume it's an inner join. That being said, I use the inner all the time, just to be clear. Because we're going to look at a lot of different kinds of joins. There's cross join, right, which you don't want to do. There's inner join. There are a couple of different types of outer joins. There's a full join. There's a natural join. There are lots of different kinds of joins. This is what they call a non-equi join. So I like to use inner just to be explicit, but it is not a required key in any platform I've ever seen. Actually, join is an inner join. All right, so let's add some things to this. I'm going to, let's say we want to see, and I'm going to go down and look there. So we've got employees, and then there's employee position. And I want to see what the columns are there. So let's do employee position start date. So I'm going to add that. I'll break the line. Employee position start date. And I want to know what the position name is too. I think it's position name, okay. That means we need to add a couple of different tables. So we've got the inner join with employee, which is fine. And I'm going to do another inner join. You can just keep adding inner joins. So I'm going to add inner join to employee position. And then we have to say how they relate again. On employee position, one thing I do miss about SQL Server is it had IntelliSense, so I could just click these in. And it would be employee key equals employee key. And then we also have to do a join with position, job position. The reason I named it job position, remember, is because position, as you might have noticed, is a reserved word. And then we have to say on job position, spelled right, is that right? Okay, position key equals employee job position dot position key. I'm going to show you a couple of things about this when I'm done with it. One, I'm going to move this down a little so I can get all of that in there. So the point of this is you can do as many inner joins as you need. On a complicated database, you can maybe have 5 or 10 different things if you need to join enough tables. So in the select clause, you list all the columns you want to see. Don't worry about what table they're in, right? You just list the ones you want to see in the order you want to see. You don't worry about what table it is. And then down here, you go through the tables. And how do you know what joins? You'd have to know the structure of it. If you have a diagram, there's a diagram in the book, and I could probably go open the one in Lucid Charts for it. Or you could look at the tables. Like, person is joined to employee by person key. Employee position has the employee key in it, right? So it's joined to employee by employee key. Job position has a position key, which is an employee job position. Well, actually, that should be a position key. I should have a key at the end. And if we run that, it should show all this information. Whoa, what did I do? Oh, I left the semicolon in there.
33, employee job position, it's just employee position.
Say, oh, it's,
On line 33.
that should be,
The last line.
it should be just employee position, yeah. Typing is a problem.
And then you have position, that's it. It's just
Post,
the T in there.
position, oh, position.
Constitution.
Oops, I got rid of the wrong letter. Position,
And then after on, shouldn't job position be?
that's still wrong, so this one needs to go away. After what?
After on, job position. Shouldn't it be capitalized?
It doesn't matter. Capitalization doesn't matter.
Spelling of the position still wrong on 33.
It's still all over
Capitalize. And the blue one.
that one. How did I do that? Position. Okay, still doesn't like.
And then in our select, we have to say which employee key we're using now.
Yes, we do ambiguous. Although it doesn't say ambiguous. But we do have to say what employee key. So let's do employee dot employee key. You guys have good eyes. I was talking and typing and not doing a good job of it. There we go. So this one, we've got information from 3 different tables, right? Or 4. So we've got person table, which is where we get their names, the start date from employee position, and the position name from the position table. So I guess that's 4 tables. Yeah, I had lots of typos, so if you were typing exactly what I was typing, you might have some problems. Let me get the gray off of that and see if that makes it. So I just wanted to show, I mean, you can join as many tables as you need to. in the book, I did do a caveat. If each of these tables had 1,000,000 rows, the more joins you do, the longer it takes to process. The joins are what they say are expensive in terms of database time. The only time that it matters, you should usually do the join, but sometimes if you're like Amazon and you need to do a sale like that, to have that information up there, joining all the relevant tables may take too much time. People aren't willing to wait 2 seconds, let alone 5 minutes or 10 minutes for a join to happen. So they do a thing called denormalization, which I'll show you when we do views. Postgres has a thing called materialized views. Views are usually just stored queries, but you can store data in this. The advantage of that is that when you call it up, it's really fast because you're not redoing the joins. The disadvantage is that it's not live data. So what happens, and this happens on Amazon a fair amount, quite often actually, you can buy something that doesn't exist, right? It's already been sold. And they'll either try to dig it up somewhere or they'll sell you, sorry, it's gone. So, yeah.
Steve, is there any difference, or is it in practice if instead of joining 3 at once, you join the first 2, and then separately join the third step?
So each step is independent of the other. The only way you could do that is if you joined the first 2, created a view or a table, temporary table, and then rejoined it.
There's no advantage to that.
I don't think so. I mean, you might be able to step it. Typically what they do, as I said, like Amazon, is they pre-join the queries, they pre-join the data, they do what's called denormalization, and then they repopulate it like every minute or so, maybe even more often than that, to try to prevent the idea. But the thing is, when you're querying the joined thing that's already pre-joined, it's just faster. And you can index it. We'll talk about indexes later in the quarter too. There are lots of things you can do to speed it up. That's just a minor thing. With most databases, you want to go through the inner join process. And it may not, unless you got millions of records, it's not going to materially affect anything for quite a bit. I wanted to show a couple of variants on this, and then we'll move on to other kinds of joins. So one of the things I'm going to do, so I'm just copying the whole thing. You can, yeah. What is it? Oh, so up here, we're doing it for the employee key. Why is that? Run it again. Let's see. Oh, sorry. Did you get used to it? How did you use it again? Didn't wipe the screwdriver.
Because you haven't spoken.
You following my. I'm sorry. Yeah, I'm going. You're following my spelling habits. So. Okay, so I recopied it. I'm just going to show you something you can do. I generally don't do this. I'm going to do P for employee, E, and then I'm going to do, actually I always do this when I'm doing it for myself. What I'm doing is I'm aliasing the tables, and so let's do JP.
If you use an alias, can you use the full name of the table elsewhere?
No, if you alias it, it has to be the alias. So up at the top, I'm going, actually, so this was job position keys, so this one should be, this one should be EP. Up here, if you're going to do employee here, you have to do E. And you could do E or P up here. You aren't allowed, if you alias the thing, you have to use the alias, even in the select.
Even though you just have the alias down.
Right. Now, one of the things, so I'm aliasing all of these, and what it saves you is a lot of typing. The disadvantage, why I don't usually do it in class, is that it confuses people. They get lost easier. So I've named person P. So whenever I want to talk about person, I need to do P. I named employee E. So whenever and it doesn't make sense to alias them with a big name because your only point is to say typing.
Why does it turn P red? Is that a reason?
There must be a reserved use of P. C does the same thing. I'm not sure exactly.
Essentially, you can name it whatever you want.
You can name it whatever you want. Again, the idea though is you probably want it to be short because the whole point is to save typing. Again, the disadvantage of this is particularly when I'm up front here, is that it gets people confused. The other thing that it does reveal though, even though this is you asked, even though we haven't aliased up here yet, these things are not processed in the order you write them.
Yeah.
Underneath, it's going to, the first thing it does is it pulls these tables out. And then it joins, then it does the joins. And then it applies the criteria, and then it looks for the fields. The very top line is actually what it does last.
Is it like identity works in typically like the alias, or do you go write it out typically?
I would suspect, see, I always alias it if I'm doing it for myself, because why type the stuff out? And as you've seen, I'm not very good at typing them sometimes. But up here, I would never, it depends. For documentation purposes, if you were doing it formally for a company, I might actually spell it out. Also, as I said, when I'm doing it for class, I will generally spell it out just because I have found people get lost easier. And when you're doing lots of, when this is most useful is when you're doing lots of joins, but it's also when you're more likely to get lost, right? The more joins you have, the more complicated this is to be. Yeah.
It's just for you named it, you name them by following the first reference to with some kind of letter.
Yeah. So it's always on the from or the first mention, yeah.
And how long does it remember those?
So all of this is only from here to here. So there's a thing called a transaction, and transactions are automatic, although at some point we may take over. I'll show you how to take over a transaction. Generally, you don't want to take over transactions because it freezes the database while you're in process. But these are a transaction. From this statement to this is, once it's gone, it's cleared from memory.
So if you do another,
If I do another one, it won't remember mine.
there's no way to store them in the database. Like they're always there.
Yeah, no. Well, I mean, I suppose there's some way you could create a table of the why. I mean, you could.
Just so you know.
But one of the things with SQL statements, each statement is its own transaction. It operates in memory and then it's gone. Okay. So yeah, you can't refer to anything in this later. Later we'll create variables too, and variables only exist within a context, right? Within a single transaction. Once you're done with the transaction, those variables have no meaning anymore. They do that kind of on purpose because of the way databases are being used. I mean, basically you want to isolate each transaction. It's part of what they call atomicity. Each transaction is independent of every other transaction. And every user, one of the things that's very unnatural about our use of the database here is that it's our own database. It's all ours on this machine. In real life, typically hundreds or thousands of people are using the database simultaneously. And it's really important that each of their actions be isolated from each other. Does that make sense? I'm going to show you one other inner join, which I would advise you not to use. This is the older syntax, and this is where you can get cross joins by accident. So I'm going to do do the same fields. So I'm just going to copy that. But what I'm going to do for the from is I'm going to say from person, and you could alias these here too if you want, but I won't. From person, from employee, from employee position, and from position, job position. So I'm just listing all of the tables in the from. Now, to keep it from being a massive cross join, I have to use where clauses, where person dot person key equals employee dot person key, and employee dot person key equals employee position dot person key. So you have to do all the same relations. And position dot position key, and it's job position dot position key. Equals employee position. All right, so I think I have all the relations. So let's see if I get exactly the same answer. Oh, I have to, I didn't, these have to be fully spelled out again because I didn't alias down below. Okay. Did I spell something wrong? Position, that looks correct. Oh, it's not person key, it's employee key. I'm having more trouble typing and talking than usual. What is the problem near select? There it goes. I think I had something selected. So it's exactly the same answer as before. The thing about this that's dangerous, this is the older syntax. In some like older versions of Oracle and stuff, this was the only way you could do an inner join. The drawbacks from it actually is a little more efficient in terms of the amount of, you don't have all that inner join on stuff. But you're conflating the criteria with relationships, right? So you're using the where clause to express the relationships. That's one of the problems. The other is, let's say I leave out one of them. So I'm going to copy this again. And the reason I'm copying them is so that when I post them on the blog, we have all the examples. So I'm going to say, I'm going to make this an accidental cross join. So notice we've got 9 records here. I am going to just cut out this end. What happens? I just cut out a relationship. And with this, it's really easy to do that by accident. So now I have, let's see, I have 63 rows instead of, right? I've got an accidental cross join because I left that relationship out. This can never happen if you do the inner join syntax. You can't accidentally leave a relationship out, it'll fail. But if you do this older syntax, if you leave out a relationship in the where clause, it just does a cross join for that relationship you forgot to express. And again, the only way you would know that this happened is if you look at the data. I might be able to see it. Also, you were expecting 9 rows. We've got 63 rows. It could get worse than that. But it's also possible that it would sneak by, right? So I'll just say,
But it's still giving you the result.
it's giving you a result. It doesn't throw an error, but it's a meaningless result, right? I think I'm going to do one other thing with these, and then we'll do the other joins. There's other things that can happen in an inner join that can mess you up. Yeah. What do you mean?
Like, we go from the person to the classroom, right? But then also get their something from another table.
Well, you can do multiple joins. We did that.
Oh,
I mean, we did that up here, right?
but going through, you like take it one path, right?
Yes.
And if you wanted to take whatever you're going through on that path, go through a different path and take something somewhere else.
You'd probably get a lot of duplicate stuff.
It would.
Yeah, or if it would even do it at all.
Oh, okay. You would just do 2 separate statements.
Probably. I'm not sure I understand quite how you're thinking about it, but yeah.
Okay.
Generally, the relationships are one way.
Okay.
And you can tie everything to everything by just going, like it's through a path.
Oh, okay.
Yeah.
So you wouldn't take 2 different trips if you just do it.
If you take 2 different trips, what you could end up with is a cross join where the 2 trips don't connect. If they don't connect, does that make sense?
Yeah.
All right. I want to show one other danger of these. So you can do aggregates here, right? But I want to, and generally these are really good. So I'm going to do, select. Oh, what do I want to add as the, so let's do, I want to do a join, I'm trying to remember what I want to do here. I know what I want to do to cause the problems. I'm trying to remember what I want to do to not have a problem here. Well, let's do a good one, then we'll do one with join with the other one. So I'm going to do extract, remember that? I'm going to do year from cat type, grant application date. Is that right? And we'll do that as year. And then I'm going to get also the grant type name. Okay, and then I'm going to get the sum grant request amount. grant application amount. What did I name it? I should look. That's not gonna work. Yeah, grant application amount, and it's grant application date. Okay. So that's from two different tables. So I'm going to do from grant application, and we'll do an inner join with grant type. And we have to say how they relate on grant type dot grant type key equals grant application grant type key. So this will bring those two things together, and we might want to order by. So I'm gonna what? All right.
You're missing an I as well.
Grant application. What?
Just kidding.
Okay. Order by. I'm going to order by the year. You could try. I wonder if it would order by year. I mean, by the alias. And then I'm going to order by grant type name. Other thing I need to do, guys, remember, I need to group by. I need to group by the function and the grant type name. Because you have to group by everything that's not part of the sum. So I just want to real quickly show, this one will work just fine with a join. And so what it does is for each year, it gives the totals for each of these types for that year, right? So it's ordered by the year, and it gives those again. And then, so this is the totals for each.
Steve, can you explain the concept where you said you have to order group by everything?
So anything, so when we did the aggregate functions, right? Extract year from application, that's a function, but it operates row by row. Grant type name is a row by row value, but sum is a group of rows, up to including the whole table. So when you have a function like sum or average or max or minimum or count, it's incompatible with these kinds of things unless you group by them. What the effect of grouping by is that it groups by year, right? And then secondarily it groups by type. If I took out the type, but I don't, then we could get, it would just group by the year. Or vice versa, you could take out the year and it would just group by the type. Does that make sense?
So are you creating column sum?
Yes. And I could rename it if I want. I didn't name it, so I could say total or something. What? You could use as or you could not. As is one of those.
And then it just ignores sum, or?
No, it's the same thing.
Oh, so sum is like adding.
Yeah, the sum is a function that is, it's basically totaling all of the subgroup for this year, this value.
And then if you don't name your table, then it just takes.
It just takes the function name.
So if you have a track, then it will be a track.
Well, if it was a function name. Like if I didn't name this year, it would say extract. Questions on that? This is a aggregate that works. I'm going to show you a dangerous aggregate in a minute, and then we're going to move on to the others.
Why don't I have this have an aggregate order? And I'm getting an error on the group by, on where I did a cut and paste from up here.
Yeah, that's, oh, you need to extract as well.
What does aggregate mean in terms of SQL?
So aggregate means that it operates on multiple rows at the same time. You're not gonna average one row's number. The average of 3 is 3. You're gonna average a whole bunch of rows together, right? So things like average and count and sum operate on whole bunches of rows at the same time, even including if I just did the whole table. So if I do select sum grant application amount from grant application. All right, so if I run that, whoops, what did I type wrong? Grant application, why can't I type? Now what did I do? Grant application amount. There it goes. So that's the total amount, all of the rows together, all the requests, the grant application amount. Now I'm just going to add this year part, just the year. So I'm going to add this in here. I'll do a comma. I'm going to break the line. And then I will do, we're going to have to group by the year. So if I run and I need to get rid of the alias and the quote. All right, if I run that, oh, now what is it not like? I got two, no, that's fine.
Do you need a comment on that?
I do.
Okay, but not on the second line.
No,
It was running off line 15.
You didn't highlight that.
I didn't highlight it, but it was in the past working okay. See, now it works. I guess I have to select it after the error. So this gives the total grouped by year, right? So because we said add the year to that, it's grouping the total by year. And now we've got the 218 was 12,000 and this was 7,500. When I did it up here, I was grouping by two things. I was grouping by the year and by the type of grant. And that was join. There was a join on that one. Yeah.
So, yeah, on that example that you did, I'm sorry, can you just explain if you already did, I apologize, but why you did group by before order by, or why you did that?
So you have to group by. It actually is a rule
Okay.
of SQL. You have to group by every column that is not an aggregate column. If you're mixing the two. Sum is an aggregate. It operates over multiple rows. Extract is a function, but it operates row by row, single row by row. Grant type is just a column name that runs row by row, right?
So say that again, you have to group by what?
Everything that is not a part of the aggregate function. The aggregate function is sum grant amount, grant application amount. That's the aggregate function. Anything in the select that isn't a part of either another aggregate function or this aggregate function must be grouped by.
Can you draw that?
I don't know if I can draw that or not. Let's do another. So we've got the sum there. I'm going to add another aggregate function, which would be like average. And I'm going to average the grant application amount. All right, so I need a comma there. And we'll call it average. All right. So when I run, it doesn't have to be, it can be. So it gives me the average. I don't have to group by it because it is also an aggregate function, right? And it's being grouped by the year, so the year, and it's being grouped by the grant type. But it is an aggregate, right? Make it through the other joins. This is okay though. I mean, you need to kind of understand it.
Working back up that form, you can see that you're averaging grant amount. If you scroll down.
Yeah.
And you've got a sum for grant application amount. So the other two references, grant application date, grant type name, are not being aggregated, so you need to.
You group by them.
those.
And what that means is we're grouping by the year, right? So these are all
So this
subtotals
one
for
and
the
this
year.
one, and these two,
Yes.
they're not
They're not
aggregated,
sum
so
or
you need to
average,
group.
right? So we're grouping by the year, right? And then we're doing another subgroup by each type. And so these values, the average donation or the average request for childcare in 2017 is 375. The total request for childcare in 2017 is 1,500. You know, the average request for dental was 425. There was a total of $1,276.79 requested for dental in 2017. In 2018, there was $1,500 requested, and the average request was $300. Does that make sense?
Those are the concepts.
Yeah.
They put structure to your applicants.
Right, and this is really useful, knowing what, you know, how much per year. You're grouping it by year. You're grouping it by all those values that aren't part of the aggregate. That's really useful. It gives you the basis of most of your reports, actually. Other questions on that? Because the next thing I'm going to do is going to confuse you utterly.
You may see your, one just underneath there.
Where I did it more simply. That one does just the years, and that one doesn't have a join in it. One of the reasons I was doing that, so aggregates behave the same way in joins as they do in regular when we did the functions. Right? Aggregates behave the same way, whether they're in a join or a function. But there is a danger in a join. Are we ready for that? Are you having problem getting it to run or just? Okay. So I'm going to show you a danger, and then we're going to move on to other danger. Will Robinson. All right. So when you do join things, so when you're joining multiple tables and you're going to do an aggregate. So let's say we want to know the total donations by city. All right. So there's three. So I'm going to say total donations by city. And there are, when we need to do this, we need to know person address is where the cities are, and then donation. Now, if we're doing this properly, we could probably include person in there, although there is a person key in person address and there is a key in person in donation, and we could probably match the two, but let's do it with all three. So what we're going to come up with is a slightly wrong answer, just slightly. But, and that's actually more dangerous than if it was wildly wrong. So I am going to do select person, address, city. And then I am going to do some donation amount. Okay, so this, what we're interested in is the total donations per city. Okay, so, and if you wanted, you could alias this as city. The double quotes are optional if it's not a keyword. So I'm going to do from person. You could, as I said, you could leave person out, but I'm going to do it from person. I'm going to do an inner join. So on person address. So on person key or person dot person key equals person address dot person key. And then I'm going to inner join donation on person dot person key equals person or equals donation dot person key. All right, this will work. Oh, except person address city. What does it not? Oh, I didn't group by, right? I didn't group by. Group by person address city. So it should work now. Will it run? No. For some reason, I have to select it. All right, so these are the balances per city. Now this is subtle because let's, I'm going to bring up, you guys don't necessarily have to do this, but I'm going to go down. I'm going to get a calculator. All right, and I'm going to add those up because when we do a total sum, they won't add up the same. So I'm going to do 250 plus 950 plus 350 plus 6150 plus 2500 plus, wow, Seattle. Well, I guess most of them are in Seattle. 64 520 dot 45. I could probably leave that out. 45 plus 750. All right, so hopefully I got all those correct. Oops, I did another plus, but let's do equal. Yeah, all right, I know. Let's get rid of that last plus. So we get 75,470 plus 45. But if I do select sum donation amount from donation. Okay. Let me just run it. I get 71,000. So let me bring that back. 75 versus 71. Does anybody know why the difference?
Maybe
one person having the two different addresses?
So some people have more than one address.
No.
If they have more than one address, their donations get doubled.
I also had a no value.
Yeah, you do have a null value for the first one. There's somebody that has no city listed. But what happens is that in between in this join, because some people have multiple addresses, their donations are doubled or are tripled if they have 3 addresses.
Isn't that an error in designing the database though, Pat?
Well, it's not so much an error in design of the database, but because some people have multiple addresses.
Right.
But if you're doing an aggregate here, you probably don't want to go through the address, person address. Or you have to do, and I'm going to show you next chapter, I will show you how to do this with distinct on.
Would it make sense to design it with a primary address?
Well, sometimes you want all the addresses.
Right, you can have it, but you can send the person 3 letters.
There's no relation of address to donation, right? There's only a relation of person key. So
Everybody has one address for the taxes.
you could maybe do that. I'm just, this can happen in a lot of different situations. The trick is that when you have joining tables, sometimes you get things duplicated because there are multi-values that you aren't showing in between tables. It's just something to be aware of because you can get really, again, this is dangerous because it's close, right? It's not something that you would necessarily instantly key that's wrong.
So is it double counting the donations that you're saying?
It's double counting the donations of anyone that has more than one address.
So before you run this, you should run and compare the tables to see if they're duplicate.
You maybe should want to do, so if we did,
You could run a check on that.
you could run a check on this. Seems like I did run a check in the book. I'm just looking to see if I have it. I did something. I just don't remember what I did. There are ways to check on it. Are we gonna? So the fact that there are some double things. So if we did, one way you could do this is do the same thing. So we're just selecting person, address, city. So when we do that, I'm trying to think of how we'd separate out the city. I mean, one of the things you could do is select, whoa. So let's do a the join without the sum, I guess. Select person, address, city. Yeah, what did I do? So I did the same donations from person. So I think there was something up above that too, right? So I had a person, one of the people I did was person 7 just to show. Person key 7. has two cities or two, you know, so person, address, city. From person, address, and let's do donation amount. From person, address, and then we will do inner join donation. There's a couple of ways we can do this. So I'm going to do on person, I'm going to cheat here, person address, person key. Where?
Donation.
Among, donation amount. From person address equals donation dot person key. And I'm going to say having count donation amount. This is different than I did, and it may greater than 1. See if that works. I may have to put the count up above. Oh, I have to group by because there's a well, if we do it simply where person key equals 7. Which is what I think I did. Now what, oh, because it's ambiguous. Where person, well, let's do our donation. So anyway, this is the same person, and this is the same donation, but they have addresses in Seattle and in Bellevue. Right? And it's doubling, I just wanted to show it's doubling that, it's doubling that $2,500. One 2,500 is legit, and the other is a copy. Yeah.
I have a question.
Sure.
Like the first example, if you scroll up, like right, just a little bit above that.
Yeah.
Right there. Maybe I'm missing something, but all you want is the person, address, city, and the sum, right?
Right.
So like, and so you took from person and you interjoined the person address table.
Right.
But did you have to do that? Because I think the person
You
address is just in the address. Did you have to do the person?
well, so you could do it this way too. You could join him on that. But it's not primary key to primary key. You're joining foreign key to foreign key there.
If you had a table of 1 million people, how would you design the check for that? Did you basically pull out the addresses and count them or anything that's greater than
I think one of the things you just have to know that some people have more than one address. If you knew that, then you would know that this kind of join would do that.
You
I'm
guys-
not sure a good check for that, other than what I just did.
You knew that person.
Well, I knew that person, but one of the things that I would do is this, right? So I get that, and then I would total that up, and then I would run to see if it matches. So if it doesn't match, you know that there's probably some value sneaking in. So then you'd have to figure out where could the multiples come from. So, and that would be in our case. So we've got 3 tables that multiples have to pretty well come from the person address.
So couldn't you, so you could, or could you look for unique addresses and count those? If it, well, no.
No, so unique address.
Unique names versus unique addresses.
So there is a way to do this, but it's not doable in a join here. So the way to do this is you have to use distinct on, but you have to do distinct on person key for, or distinct on donation key, not person key. But if we do that here, it will just give us all the donations. We want group by. So the way you do that is what they call a common table expression, which is next chapter. Right, because it won't work with just a straight join. You'd have to do it. Basically, you have to do you create a subquery that differentiates out only unique donations, and then you do the join based on it. So you basically create a subtable, like a temp table, but it's what they call a subquery, and then you query the subquery.
Is that what you use for your correct total?
Yeah, that would give you a correct total. Actually, because in the book I actually note that this doesn't work, right? And then in the next chapter I show you how to make it work. But all I wanted to do here, we spent a lot more time on it than I meant to. We may or may not finish joins today. Is that there are dangers in joins that are not necessarily obvious, right, when you're first doing it. And you should just be aware that you can get a false value when you're trying to aggregate across joins. If you make joins where there's multiples in between, and it's not always obvious that that's happening.
So because what we're trying to do, we're trying to find.
We just wanted to know what was the total per city, right? So we're just doing a report. We just wanted to know how much on average was donated, how much total donations did we get from each city? That's actually a legitimate thing to ask, right? It's just that there's a little bit of a danger there because some of the things are duplicated. It's not a huge duplication. It could get bigger. In fact, if the data table were larger, the difference would be larger. Does that make sense? There would be more numbers involved. Yeah.
And sorry, can you go a little bit above, just so I can ask more questions? Oh, actually, no, that's the example. Right,
Yeah.
actually, there. So, on the second inner join on line 82,
Yeah.
maybe this was the point of it. I'm sorry, I'm a little confused. Why was it on person instead of on person address?
Well, so because actually the person key is a primary key in person, right?
But like logically, like the first inner join is connecting.
Person
First
is tied to all of them. All right, so everything is tied to person. It will actually work just fine if I did person address, person key here, although it's a little bit dicey in terms of the logic of it because you're joining two foreign keys. You're not joining a primary key and a foreign key, you're joining two foreign keys.
So your first on should always be the first from.
Yeah, I mean, it works essentially the same because of the group by and etc. But there are multiples of these and there are multiples of these, right? The same person key can repeat multiple times in both tables if I were to do person address. It works, but this is probably logically a cleaner way to do it.
I always thought they're supposed to connect in a logical form as
They are. So person connects to person address and person connects to donation. And it's actually maybe that kind of relation where the sneaky stuff is most likely to happen. Let's see if we can do, are you guys ready? I'm not sure we're going to finish all of these today, but there won't be too much left. I want to do outer joins. If you're confused by this other stuff should confuse you more. So outer joins, unlike an inner join, an outer join is really designed to show you things that don't match, right? Inner joins show you all the stuff that match. Outer joins are about not matching data. So it's a way of, so let's look, the one I have, this is an easy one here, but I'm going to select the grant type name. And then I'm going to do grant application grant type key. All right, so I'm going to do from grant type and then we'll do a left outer join with grant application. And then we'll show how those tables relate again on grant type dot grant type key grant type key equals grant application grant type key. So an outer join again shows things that don't match, and I'm going to kind of show you how. In this case, it does matter where the grant type key comes from. I want it to come from the grant application. So a left outer join means from the first table, this is the left table, list everything, whether it has matching columns or not, but only list matching ones from this table. So what we end up with,
Missing an A in that.
where
191.
application grant app,
91, it says grant application.
application.
And grant type. Grant type.
Accuracy.
Okay, so grant application, and this one needs an extra, grant type needs an extra T. It's a good thing you guys have good eyes. Oh, and then I need to, for some reason it's not running.
190, 190. I think another two. Okay.
No, it's got two.
Oh,
One is capitalized, one's not. Oh, and let's do distinct. All right, so what you find here is that there's a couple that are null, right? So it returns everything in grant type, you know, all the different grant types. And it returns the, I made these distinct. So this is the grant type key, but this is the grant type key in grant application. There's a couple that are null. That doesn't mean they're null in the actual grant type. It means that they never occurred in the grant type. There's no relation. Nobody has ever requested funerary. Nobody has ever requested travel. Right? So those have never been requested because they don't have any matching values in the grant type table. So that's what an outer join does. So on the left side, this side, it returns all the values, even if they don't have match. Funerary and travel do not have match. In the results set, it puts nulls to indicate that. Which means that if we want to only look at the unmatched values, we can do the same thing, but just look for nulls. Where it's interesting, I did that up above this one, but oh well. So I'm going to just say where grant application dot grant type key is null, and it will show me, oh, and where is typed wrong? Okay. It will show me only those two that have never been, you know, never been called on, never been asked for. So if you're looking at this, if you had like a product list and you had what products that nobody's ever purchased, or if a library, what books have nobody ever checked out, it might tell you something that you could get rid of, right? It's also a way, though hopefully your database is designed so this can't happen, but if you have orders that don't have a person, right, you know, then you can look for those. You can look for unmatched records. That's what an outer join does. There's also a right outer join. The difference is which table returns all the values.
The second,
So the left table is the first table you list, and the right table is the second table you list. So if I said right outer join, it would return all the grant types, but only the matching, only the matching grant type names, which really would show you nothing. I mean, it would be a lot like an inner join. But I could do this exact same query as a right join by just changing the first thing to grant application. And then making this a right outer join on grant type. And this is exactly the same query, just with the flipped. Oh. Did I do?
This is an A grant application.
Why am I just can't type today. So, and then I didn't have the is nulls, but it's exactly the same. I always do left, just because that's the way my brain thinks. If you prefer to do right, I suppose if you had a Hebrew background, where they write right to left, you want to do right.
What's the thing you can learn left?
What?
Like why?
So it's used a lot when you want to find outliers. You want to find things that don't match. So a lot of times it's used for cleaning things up. Again, looking for a product that never sold, looking for a customer that never purchased anything, right? They registered to purchase, but they never purchased anything. So you might want to weed them out of your database. So if you look for, these are used quite a bit. They're not used as much as inner joins, but they are used.
And there's no difference between right, outer join, and left.
Yeah, the only difference is which table you list first. Right. So if you do a left outer join, the first table will return everything in it, whether it has matches or not. And the second table only returns matching values. Does that make sense? And in this right turn, this one, the first table listed only returns matching values, and the second table returns all the values. The difference is just which table. I don't know why they bother. I mean, you could do left and you could do right. They're the same result if you flip the tables. Like if I left the tables the same and changed it, then I would actually not see anything other than what an inner join was doing. It depends on the tables. Here's another variation of this, and then we might make it through. There is a thing called a full join. And a full join actually, I'm going to just make this a full join. And I'm going to just make this full. It returns exactly the same thing. What a full join does is it returns both tables, whether they're matching or not. So it just returns all the values from both tables. But again, where they don't match, it will return nulls. If there was anything on this side, that was over here but not over here, which again, in good design shouldn't happen, but it would put a null over here too. A full join just returns everything from both tables, whether they match or not. Right? So it has the same effect most of the time as an outer join. The one thing about full join is that it's not supported by MySQL, it's not supported by Oracle, it's not supported by a lot of different, they have outer joins, but they don't have full joins. And it is an ANSI standard thing, but it's not supported by Oracle or MySQL. All right, trying to think of what other joins we've got. I think there is a thing called a self join, but I'm pretty sure I didn't ask you to do that. there's a thing called, there's actually two variations I want to show you on inner joins. One is with using, and I don't know if this is ANSI standard. I'm going to say, let's just do select. Let's go back to, I'm just going to copy one of the early joins. Let's just do like this. So this is way back where we were doing just the join of employee in person. One of the variations is you can do using person key. And this will give us exactly the same result as it did by doing the on. Right. This is a variation of the syntax. It is supported by ANSI, but as far as I know, no other databases implemented that. So I would generally suggest using on in the relationship, just because if you get into the habit of doing this and you go to SQL Server, it'll say, huh? It'll just throw an error. Yeah.
Would that only work if both columns are named the same
Exactly.
thing? So if you had like person key in one table and then the foreign key was,
Like foreign key person or
Yeah.
something, it would not work.
okay.
This only works if they're named the same, right? If the columns are named the same. I always name my foreign keys the same as the primary key, but you don't have to. And a lot of database managers won't, or database developers won't. They'll do something like FK person key, or something that distinguishes it from the primary key person key. Does that make sense? Or FK person ID, or whatever. Now there's another one, which is kind of the same principle, which is a natural join. And again, natural join isn't widely, so instead of this, I'm just going to do natural join, and I don't have to do even this. Pretty sure I can just do that. Oops, I have to highlight it again. It's not running them if I don't highlight them. Same result. I don't even have to say how I use it. Again, natural joins only work if the person key is, if the primary key and foreign key are exactly the same.
This is like an assumed use.
Yeah, it's an assumption, right? It's assuming that you're using the same thing. If by some weirdness, bad database design, you had two fields that had the same name and something, it would, it might screw up, right? If you had, if again, bad design, if you were to put in, say, the employee name or person name in the employee table, it might match on the in-person name instead of the, person key. If there's two columns that are the same in the two tables shared by the tables, it chooses one, and it may not choose the right one.
Wouldn't it be a lot more work for the
I suspect it's less efficient.
do all that math?
Yeah, and the other thing is that this is not widely implemented in other database management systems. But it is an ANSI standard, and it makes things really easy, but I'm not sure if that's a good thing. So these two are two variations. They're both inner joins unless you specify otherwise. A natural join assumes an inner join, but you can make it an outer join. I'm not sure how you make it an outer join, though. I'll have to look. You'd have to do something like natural join, outer natural join or something. And then maybe left natural join. Actually, the outer keyword is optional. Left and right are not. But And this one, you can, it assumes an inner joint too, but you can do an outer joint there too. So those are two variations. Is there anything that I forgot to cover in joins? So I didn't do self join, but those are kind of rare. That's where a table joins to itself. It's in the book. So we did natural joins. I think we covered most things. And if you were to do, like if you wanted their address too, maybe let's just add city. Person, address, city. Then you would just add another natural join person address. And it should still work. Okay, so all of them live in Seattle. Again, that's kind of neat in that it saves you some typing and stuff, but it's a little dangerous, and it's especially dangerous if you're going to be moving between database management systems because it's not widely supported. I'm trying to remember if SQL Server supports natural join. I think that's all for joins. It took us, well, actually did pretty good. The aggregate discussion is good because it's really important to understand those because so many reports are based on aggregates, so we can come back to it again if we need to at some point. I'm pretty sure that's all the different kinds of joins I wanted to cover. Oh, you know, there's a non-equi join, but I don't think I asked for one in the assignment. Non-equi joins, notice how all of our joins use an equal sign. A non-equi join is where you do something other than an equal sign. I'll do, this isn't part of any assignment, but we got a minute, so I'll do it. And then I will give you Open Lab on Tuesday, unless you guys are really productive over the weekend somehow. Let's see if I can get a non-equi join. I know I did one, I just don't know where. Here's one. So I'm going to do person and donations, and I have grant application too. Well, select in front of that, of course. Yes. I'm having, as I said, more problems typing today. So I'm going to do donation date, donation amount. And then I'm actually, these things don't relate, really. Grant application date, grant application amount. All right, and I'm going to do from donation. And I'll do on person key equals donation.person key. So we're going to do the final part. This is on showing the relation first. And then I'm going to join grant application. This is where I'm going to do the non-equity. Oh, so I do need a join there though. From donation, and the first join is just person. I see what you're commenting on. And then we're going to join grant application. And again, inner join will work because I'm just doing, actually, it assumes inner join. But I'm going to do this as a non-equity one. I'm going to do on grant application date between, and I'm going to give it 2 dates. Between donation date and donation date plus interval 7 day. So what we're gonna do is we're gonna look at all the requests made within 7 days of a donation. And then I'm going to order by person, last name, person, first name. I haven't looked at this for a while, so let's see what this turns up. So this is complicated, and this is not part of the assignments. Oh, so what did I spell? Grant application date. So this is the donation date. This is the donation amount. And these are all the grant application. Notice how with Tom Baker, there were 2 applications. Let's just look at one of these. So I'm going to just add where, actually that goes before order by. That's kind of what I gave you. So we're just looking at those 2. Basically, it's saying that Tom Baker donated $2,500, and within 7 days of his donation, 2 people asked for a couple $100. It's a weird. I don't do non-equity joins, and if you look online, so it's a non-equity join because we're saying we want to look at only the ones between these dates, right? We're not joining the person key into the grant application, so we're not getting the people that ask for things. We're just getting all the donations within 7 days of their donation date. Right. So these are on the 21st. This is on the 25th and the 28th. So they're both within 7 days. We're just looking at it's something you could do to a donor, right? You could say you donated this money, and within 7 days of your thing, these people asked for money. So your money is going to these kinds of things and whatever. It's a weird query, and I didn't have you do it because they are weird. But you don't have to do an equal sign. You can do ranges, and you can do different.
Maybe kind of prove something too, or maybe try to find some correlation between the politics, the travel date.
You can probably use this for correlation kinds of things, yes. but as I said, they're kind of strange. I mean, if you really want to play with them, you could probably get good at them. But having it come up with meaningful data isn't. You could maybe do, yeah, travel dates versus, or since the shutdown, the approval ratings have been going down. You could probably do between these dates and look at the polling. You know, there's no direct relation between the tables, but you could make a relation based on the dates.
Donations to some political
Yeah.
person during the time they were in Russia.
Yeah. So I mean, it is possible to do these kinds of joints. Okay, so I'm going to copy all this to the blog. I will post the video. Have a good long weekend. And if you need, I will give time on. I assume you will need the time on Tuesday to work on it.
We're gonna use all the classes.
What?
We're gonna use all the classes.
I would assume that we'll use the whole class for Open Lab. Now, the only difference, and I will announce it if there's any difference, but I'm assuming that it'll be Open Lab on Tuesday. The only reason that I would not is if I go to grade on Sunday or Monday morning and I see that half of you have turned it in or something. Yeah.
Can you do a ERD printout?
Let me see. So,
More specifically, can I?
yeah, I might actually make these books. I'm going to. I want to stop the video real quickly. In the first chapter, I explained how to make a ERD for that, but I do have an ERD on Lucid Charts. So if I do lucidchart.com and I log in, so you want community assist or tech? Do I have the tech one? I might have to make one. Actually, it might be here. I could probably share it, but let me open it. All right, so this is the community assist, and this is not.
And do you have one for the text certificate?
Well, that's what I'm looking for. I thought I had one up here.
They're both would be interesting.
So let me.
It's disappeared, so it's lost.
So I want to close this one. File. Feature find. Connect to Google Classroom. Share. Present. Feature find. Sheets. Close this. I'm just trying to get out of this one now, which shouldn't be that hard.
Seattle Central.
That's the, that's right.
That's
Oh, I'm pretty sure this is it. Whether I can get it all on a page to print. Where am I printing to? Turned it into a PDF. Let me save it and maybe I can print the PDF. Let's see what comes out. It may or may not be readable.
You gotta make it hard.
Maybe I'll print another one and make copies.
That was not the,
This is the.
I thought that you were going to
Can you
have a
post that?
copy, but that's a question as well. Just so I understand. So I went through each of these just to kind of see it. I have to do that. So when you join, or when you do the on here, you're not doing it in the traditional sense, not whatever, you're doing it in a new way.
Yeah, that's what's called a non-equijoin, because there's no equal sign on the second on.
It's called a non-what?
Non-equijoin.
Non-
EQUR.
Okay.
In the sense that it doesn't use an equal sign.
Oh, got it. Okay, and then, so this part here is my right question. Does this mean that someone requests, like, is Bob Baker the requester or is he the donator?
Well, so he's the donor.
He's the donator.
And we're looking for everything, what we're joining the tables on is the donation.
Right, so,
And we're wanting donation dates between the donation date and 7 days.
so does this mean that someone requested
Somebody requested 200 twice.
within,
Within 7 days.
and that's what this means, is
Right.
Tom was trying to.
He's not the one, he's the one that donated the money.
Right, and then someone requested that.
Yeah, so we're just showing the donor that there were requests.
We're meeting.
Yeah.
Okay.
We need a signature again.
Oh, he had it.
Drop you off again. Be down there in a moment, so. So I need, it's just this class, so the first one,
Yeah.
He said that in his first
oh,
lesson.
3 months. And so that's 172. Okay. So I just do, It's
You
not,
want to divide like that, 220 and 170 instead of this.
I think that's okay. But I need to sign the first two. I need to put my name in. Oops, two. And one, today's the 17th. And then I need to say how long you've attended class, which is from the 2nd. So hopefully that'll work for you. Okay. Yeah, go ahead and.
I'm assuming that's the.
So, what the county person for? Yeah.
Depending, you can, yeah, you can keep it.
And then.
First year.
Yeah.
That's one that will. Never home. See, when I did research, two things. Like, I gotta have a low. Which you can't get. 25 years.
So this is.
I like.
So if we want to order by, we do by the next line down.
In other words, he was just sold, there's this stuff, so he's not going to mark it up.
On Tuesday? I'm not sure. Oh, for even next quarter? No. Oh, you mean the next quarter, class in this? No, I'm not. I'm gonna take off for a second. Sorry. Are you?
Yeah,
Okay.
like, slightly, we'll have a few questions. Just 16, I just get
So let's do. Select counts. And then do a comment. After this. And then do average. so actually, let's not.
Looks like there's no word on there. Yeah, but that's just like.
So you're at the staff meeting? You don't need that. So, cancel. And then just go Okay, so I need to, so several were printed here, I guess, whoever wants them.
That's all, thank you.
Yeah.
This is for.
That's for the, yeah, it's for the homework one. I can print one for the other one.
I was trying to copy this and I went to a different accident, but I saved it before, so I just, so I'm more like, what?
You can do all, just save it.
I didn't save it since this.
So say,
I'm not unsure what it's for.
so say now, you disappear, you tried to copy it away.
Yeah, I don't know.
So you sign
I did save it before. If I just open my own copy. Or maybe if did I just, oh, you know what, it just went down. It said 1, 2, 3, 4, so I thought it was the beginning.
well, I just did Control V.
Oh, maybe that's what it was.
So if you accidentally wiped it, I may have just re-added it. But I also, it looks like I copied a lot of white space.
Oh, that's fine. So I was trying to copy the code. It's like my.
So you should do like Control A,
Right, but it won't like, well, sorry, Control A, I know.
Control A, Control C, but it won't copy it out of the,
Yeah, so how do I like save it or print it somewhere within here if I can print it?
so you could pull up, so you can save it. What are you trying to do with it?
I want to print it somewhere or like use it or email it or something of that nature. where I
So you
can,
just open up a web page.
So just, I have to like log into my email. through here.
Yeah, you need to do it internally, I think.
Okay, because even like on the main here, I noticed this corner, Word's not in there.
No, it's not. They did that deliberately.
Did they take away like those licenses?
Well, we don't have the Microsoft thing. We do have the Microsoft. By being a student here, you have the Office 365.
Right,
They want you to encourage you to use that.
instead of one of this. Really?
Yeah,
The features are not the same that were on.
they're not exactly the same now.
That's not.
If we installed the tools for VMware, it would cut and paste across, but it's kind of complicated in Linux to do that installation, so it's all done at the command line.
And it's, a lot of the stuff that I'm doing is like stuff that you heard over and over about, yes. It's like, it's stuff you can infer as just a normal person, like, hey, you know, internet, and that happens in other things.
Yeah, me
So,
too.
if you, means that you can order things to be delivered to your door. Like, you know, it's like, we'll back you up on that one. Like, I'm pretty sure that's a logical, like, fairly logical leap that that's New York. Well, I actually did come up with a couple of interesting articles about how, I don't think I actually, I'm not using it here, but they're super interesting about how like it's like always it's like you've done like HTML, it's like you're doing like structures like it's stuff like that where it's like you know and making sure that the website is relatively
Last question I have.
Sure.
I just want to make sure. So this one is a per section, right?
Yeah,
And when I run it, it's at that.
right. So what you want to do, so list all the who have an average grade. So which one? This one is, what is the final grade per section? So,
Average.
right. So what you want to do is section key.
Yeah, I put it in.
But you wouldn't average the section key.
Yeah, but you said average.
Right, but you wouldn't average the section key.
So I put it in section key here.
So you want to do section key. And what you want to average is the final grade. So just put section, select section key.
So select section key,
Comma.
comma.
Okay, and then in here, you want to average the final grade.
Oh, final.
And then you want to, after the from, group by section.
Oh,
So just put,
this
so,
is not like two tables coming together.
no, it's just one table. Not order by, group by. You might- So you want to group by section key. And then if you want, so then you can do order by section key. Group by is different. Group by is,
Group by is like,
it's going to group the final, for each section, it'll give the average.
oh, so it's gonna go by final and section together.
Yeah, it's going to give you the final, the average grade for each section. So the group by gives it by each section. The order by will just put them in order. It'll just sort them. by price section key.
This question is like this. The guy in the video didn't know how to do this.
So if you run that, that should give you more of
So
what
you see group by
So
section
you
key
go outside.
Right.
and order by section.
That's right, and then we included the section key there so you can see it, and it should give you the average grade per section. So section one, the average grade is 2.96. So each one of the sections gives you the average grade for
Oh,
that section.
so each
Yeah.
section. Okay, now I get it.
Okay.
So every time we use group by, that means it's gonna.
Group by, yeah, gives you basically like subtotals or sub-averages. Yeah.
Okay, thank you.
So I have posted the code. The code is on the blog, and now I'm going to,
I've never. Yeah.
Yeah, I don't know, I've never actually asked it.
I've just been in these classes for like 8 years.
yeah, probably really tired of me.
Yeah. I'm so tired. No, it's okay, Steve. You're the best class. Seems like that. Everyone else can stress me out, but it's okay.